Hello, welcome to Land Timber Stream. It's Saturday. Excuse me. My day's already getting thrown off here because of the holiday, I think. But yeah, I hope you're having a good holiday weekend so far in the U.S. That is, if you're watching this in the United States, we have Labor Day Monday off, extra study time, labbing time. This wallpaper of the day is something cool I saw on Instagram. It is from the Hubble telescope, showing the aurora and the northern pole of Saturn. Too cool. There's actually a video showing that, which is just amazing. But anyway, let's talk a little CCIE stuff. This is the agenda for today. We're going to do a little bit of labbing just to broaden our understanding of a couple of spanning tree protocol things that I've been working on. And we're going to do just a new Git repo. I want to do a new Git repo for pcaps. So I'm going to get in that in a minute. But again, hoping you're having a great Saturday. We went to barbecue a little earlier, had a little bit to drink, a little bit tired, but I'm like, okay, I gotta get going here on jamming through these network lessons. I got a lot to cover. I've got 58 days, so I need to get moving. So that's what I plan to do. So Git repo. Let's go ahead and do that first, because I kind of want to share a packet capture that I have, a new packet capture. Actually, it's on my other computer. That's okay. That's why Git is really cool, because you can clone copies of a repo to multiple devices where you can keep a clone copy, and then if you can make a change on any location and push it up to the repo and then pull it down at the other PCs, right? And the nice thing about pcaps, using that for on Git instead of just using a normal, well, what I've been using Google Drive, is that Google Drive doesn't have a native reader for pcaps. So you have to go to Google Drive, you have to download it anyway, double click to open and view the pcap, so that's why GitHub is a better place, I think, to keep these and to view them, right? Ideally, I would use what's called Cloud Shark, which I have some Cloud Sharks here that we're going to talk about in a minute when we talk about convergence and message age. I need to clarify something from the other day, but this costs money to post up there. So if I ever build a site that is intended to, make money, then I would use something like this. But, all this is just community stuff for free. So that's why I'm going to switch to GitHub. So let's just do a new one. I'm going to walk you through that. If you've never done what, I'd encourage you, it's in the CCIE blueprint under Evolving Technologies. So I definitely encourage you to set up your own GitHub site if you have not already, even if you're just going to put some notes in there. So I'm on github.com, and GitHub is for public repositories. Well, I say it's for public. You can see I'm following a couple of people here too. Oh, Robert Rittenhouse. He's in the stream a lot. I wonder what repos he has. Hello World, CLS 2018. Oh, okay. So it looks like he was doing some... I'm going to guess that what he's doing here is he went to DevNet at Cisco Live, and they had him do a lab to start using GitHub. And he did a Hello World, he did a CLS, try Git, and then he's got a fork of JLord Patchwork. That's another really cool. Congratulations. Yeah, fork a branch. So this is probably just, and that's great. Everyone should have at least one or two repos, even if they're just playing around, so that you know how it works. You know how it works from the command line. And that's what we're going to do today. I'm actually going to create a new repository here. And what I was saying, though, about GitHub is public. If you want to do private repos, GitHub is not free. I think, yeah, like it would tell me here, upgrade my account, credit card, PayPal. So GitLab will let you do free private repos. Like if you're working on something that you need to use the power of, Git, but it's something you don't want to be public. So just do a private repo with GitLab.com. That's what I do. But these are obviously public, so I'm going to do packet captures. We'll just call it that. We're going to initialize it with the README. We don't need any git ignores right now. We don't need to add a license. So this is easy. You could do this via CLI. I haven't figured out how to do this part via CLI yet. Well, actually, I may have done one or two, but I don't know. It wasn't as intuitive to me just coming in here and doing it from the website. Packet captures. So we're going to say, all right, I'm going to edit that later. readme.md. Okay, so that's fine. So this repository will be used to publicly store packet capture files used during the stream and also referenced in other public posts. Okay, very simple. And what is this? I'm going to hover over this. Okay, I think that's preview changes. Okay, then you have to do a commit. And I'm going to do update first. Commit directly to master branch. Yeah. All right, so now we have a new repository. It's as simple as that. You've committed a change to your repository, and now is committed directly to the master branch. So now what we can do is clone this down to any computer, right? So I'm just going to copy this. So there's a couple different ways, right? You can use SSH, you can use HTTPS. This usually just works fine. You can download a zip. You can open in your GitHub desktop. There's a GitHub desktop client that's GUI based as well. Again, that's fine. I would rather use, if I'm going to manage repo through a GUI, I'm probably going to use something like VS Code, Virtual Studio Code. But in this case, I'm just going to copy the link because I'm going to come here to my terminal and I'm just going to reference Git from a bash shell. So let's go to I have several. This is where I want to clone it into. As you can see, I've copied Awesome Network Automation. That's Nick Russo's, one of his repos that I've cloned down. So I'm just going to git clone and the name of the repo. And done. Now it's packet captures. So I've got one file in here, but the file I wanted to show is actually on another computer right now. And I meant to set it up over there, but what I may do for demonstrating this is let's just go to Google Drive and pull up the let's see, let's go drive.google.com. We'll go to the packet captures folder. And we'll just pull a recent one down. Captures. As you can see, yeah, Q&Q, that's a good one. I love that one. That was fun. And we're just going to download. And what I'll do later, I'm not going to do this on stream because I was just updating a repo with a lot of files. And it was affecting the streaming. So it was affecting my FPS in the stream. So we copied this down, and let's now go to, I'm not sure where, I'm getting away from Brave. It's just been running slow lately. I don't know why. But let's see. Okay, so here it is. So what I'm going to do is just manually copy this into my Git folder. Packet captures in here. So now what you have to do is you have to let Git know, because Git is keeping track. Now it sees the file there, but this is not automatic. It's not automatically going to push a new file up. What you have to do is a couple of steps. One, if we do git status, and that's always a good thing to do if you're not sure what the status of things are, it'll say your branch is up to date with the origin master. You have an untracked file here. So it's like, okay, there's a new file. Unless you add it, I'm not going to track it as part of the repo. So we need to do a git add. What I often do is I just do a git add period, or Windows, it would be what, star.star. And that's going to add every new file to the local copy of the repo. So we've got that. Now what we need to do is we say, okay, we're done, we're ready. Let's go ahead and update the master. The origin, we should say, let's do a git commit. And then it opens your favorite editor. Well, it opens your editor. I changed mine later on to be Nano because I'm more familiar with that. First, pcap file to add to repo as an example. I'm going to save this. Now if we do a git status, it'll say on branch master, your branch is ahead of origin master by 1 commit. Use git push to publish your local commits. That's exactly what we're going to do. So now we're going to do git push. And now everything's in, now we're in sync, right? That's all there's to it, folks. So what I'm going to do later is there's a spanning tree uplinkfast pcap that I took earlier. I was running EvenG on this iMac, and I was in the living room on a Windows machine, and I was running EvenG HTML5 console mode. And I ran this, I was labbing, doing some stuff in there, just kind of chilling. And then I wanted to save it, so it saved locally to that computer. So what I'm going to do later is I'm going to go on here on the other machine. I'm pointing over here to this other machine. It's off right now, but I'm going to boot it up. I'm going to clone the repository to a local copy. I'm going to add that pcap to the repo. I'm going to commit it and push it. And then that will now be synced with the origin master, right? And then next time I come in here and I do a git pull, I'm already up to date. But if I do this later, it's going to pull that pcap down. Now I have a local copy. Anytime I want to look at it, reference it, I can just open the folder and double click it. As a pcap file, I'll be able to open it in Wireshark, right? Good stuff. So that's just a real simple exercise, folks. For any of those who are not familiar, many of you may already be, but that is our first repo here on the stream. We just kind of created beginning to end, and that's why I did it, right? Because it's, as I mentioned, I want to be able to open it locally in the Wireshark application. All right, so let's talk about a couple of spanning tree protocol features. As many of you may know, I have been working on going through networklessons.com, identifying gaps and bolstering, plugging the holes, hopefully. And a couple things I've found with spanning tree protocol with these, what they call the optional features of spanning tree, which is, of course, we're talking 802.1d, the, not rapid spanning tree, not multiple spanning tree. We're talking STP, right? 802.1d protocol. So with this, there were always these optional features that I struggled. I kind of knew what they did. I knew what they were for, but there were some subtleties that I didn't really have down. And I read through the networklessons.com lessons on those, and they're really good. And there's a couple things that I learned through reading that content. So definitely check that out, check out Network Lessons if you're really interested in that. They have, a free trial $1 for a week. You can try it out. Or you can do $29 a month, or you can do $290 for a year, which is what I'm doing. And it's great. There's so many little details in there that I think are good, especially as a CCIE, a routing and switching written, someone preparing for the written, that are great. So with uplinkfast, I learned a couple of things. I'm going to actually demonstrate these on stream just to solidify them in my head right now. I've already got the lab, or I've already got EvenG running. So first we're going to show you what uplinkfast looks like without or what convergence looks like without uplinkfast. Let's go into even G. And we're going to do HTML5 console, still my favorite. So what I have here is just 3 switches, and we have a host here and a host here. And let's go ahead and start things up. So what we're going to see is that switch 1 is or should be the, oh, you know what? I don't think I saved my configurations. That's okay. It's real simple. So we'll do them over again. But you're going to have switch 1 should be the root bridge. We're going to have a single VLAN, VLAN 1. We're going to keep it simple. And we're going to have this host is going to be on an access port in VLAN 1, 192.168.1.4. This is going to be 192.168.1.5. And these should be able to ping each other. And the path that we'll take here, though, since this is the root bridge, is we should see, I believe what we're going to see is that it is going to go this way. The frame will go this way, I believe. And then, because this is the root, and this port, so with this being the root, what's going to happen? That means that this will be the root port, JAZ00 on switch 2. This will be root port on switch 3, JAZ01. These will both be designated ports. This will be a designated port, and this will be an alternated port in blocking mode. So to essentially avoid a loop, this will be blocking, and that's why this frame is going to go this way. Which normally that's what we want, right? So let's open. Yeah, this is going to go back to default, I'm afraid. Switch 2, switch 3. Maybe not, I don't remember. We'll see. All right, router 4, this is like our host, right? And router 5. So I'm going to put these all in reverse order. I need to remember to open these in reverse order, actually. Things are still sort of booting up. Okay, yeah, we're back to scratch, and that's okay. Host name is going to be switch 1. Switch 2. This is going to prompt me for, don't want to do startup config. That's okay. I forgot that. That's one thing I always forget to do, is to save my configurations or export them. No. All right, so what we're going to do here is on our ports, let me bring up the topology separately. And oh, I just realized over here I'm not running my dashboard, which kind of helps me see the chat. So let me open the dashboard link. I got started here kind of quickly without kind of going through my whole process. All right, good deal. Oh, I did not update the, sorry, one second, guys and gals. I didn't update the title on the Twitch stream. Okay, now back to business here. So we've got, we're just going to configure here, again, a single, trunk between each switch. So here we're going to get a switch, we're going to shut down all the other ports because unpredictability in, a virtual environment, right? So we're going to say interface range, JI 0, 0 through 3, JI 1, 0 through 3, shut. And then we're going to say interface range, JI 0, 0 through 1. We're going to say no shut, switch port trunk incap .1q, switch port mode trunk, and we're also going to say switch port no negotiate, just because that's going to help when we do the pcaps. We're not going to see as much. We don't see all those DTP frames, which I don't really need for this lab. So let's go here now. Interface range the same. JI 0, 0 through 3. JI 1, 0 through 3. Shut. And let's take this. Well, wait. Interface range, JI 0, 0 through 3. JI 1, 0 through 3. I think that's fine. I think that's the same thing. Shut. And configure terminal, host name R4. And interface JI 0, 3. IP address 192.168.1.4. And over here, interface JI 0, 3, IP address 192.168.1.5. Okay, and I think he's good. Now over here we have to say interface range JI 0, 0, JI 0, 2, no shut, switch port, trunk incap .1q, switch port mode trunk, switch port no negotiate. Inconsistent port type. Blocking JI 0, 0. Interesting. Spanning tree 7 recede 1Q non-trunk. Received 82.1Q BPD on non-trunk. Okay, well that's fine. I will do no shut just in case. Those should be up. And then we're going to do interface JI 0, 3, switch port mode access, switch port access, VLAN 1. Spanning tree, port fast. That's the face our host, right? Okay, switch 3. We'll do the same. Interface range, JI 0, 1 through 2. We're going to say switch port trunk incap .1q, switch mode trunk, switch port no negotiate, no shut. And interface range JI 0, 3, switch port mode access, switch port access VLAN 1. We didn't have to do switch port access VLAN 1, but I like to do it anyway. So sue me. All right, so now these, let's just do a little verification. These should be able to ping each other. We might still be converging here. Show IP interface brief. Show CDP neighbor. Ah, no CDP neighbor. Let's look over switch 3. Oh, it's shut down. That's why. Let's look at switch 2. No shut. Also, we need to put spanning tree port fast. Okay, so now we should be able to ping. Unless we got some other error in our... There we go. All right, so we got our basic setup here. And here's what we expect with uplinkfast. So right now we have switch 1. This should be the path used to forward these frames, these ping frames, right, between host 4 and 5. And the way we could sort of verify that is if we see the MAC address table on switch 1. That's one way to verify it, right? show MAC address. Okay, I happen to know that this is a MAC address of host 4. Show MAC address. Sorry, so 4, right? Is this MAC address? And let's make a little, let's open VS Code. Well, we already have VS Code open. Copy, paste. Come on now. Oh, does that not work that way? I thought it did. So 500 0004 0003 is host 4. Nasquez, hello, greetings from France. Hope you're doing well. I am, Nasquez. Thank you for joining. I appreciate that. Glad to have you along here. I speak Spanish, and sometimes when I'm reading French, because it's Romantic language, I can understand. It's been a few weeks or months, yeah. Yeah, well, it's probably tough in France, because what time is it in France right now? It's probably like wee hours of the morning, I would imagine, or after midnight. So, yeah, after midnight, sure enough. So, yeah, it's probably hard to catch a stream, and normally I stream starting about this time. So I can definitely understand. Great to have you. 500 0005 003, right? Is this, yeah. Well, that's kind of a pain that that I can copy. So I can copy and paste. I had to install this extension. So I can highlight and right-click paste. But does that work here? No. Okay, so it's only within, well, that's kind of a bummer, but at least we have that. I need to figure out how to do that. Copy paste to a different window in HTML5 native console. So I'm going to make a note of that to the follow-up. EvenG native HTML5 console, copy paste to other windows. So these are our MAC addresses, and right now if we look at switch 1, we have learned both of these, right? And we should know, like if we look at switch 3, show spanning tree VLAN 1. So we see that this port is being blocked, right, to avoid a loop on VLAN 1, which is normal. This is normal design. That's what we want to see, right? GI03 is designated but that's a peer-to-peer edge, right? Which means that is a shutting down this port would not cause a TCN, which is what we want. And GI01 is the root port. So that's good so far. So now think about what will happen here with uplinkfast. What happens if there is an indirect link failure? So let's say switch 2. Actually, let me think about the best way to illustrate this. Okay, so right now this is blocking. This is an alternate port. Let's say there's an indirect link failure here. So for example, if we were to shut down this interface, GI00, and it's funny, networklessons.com uses a big chainsaw symbol to illustrate. It's kind of cool, but let's say that this breaks our normal time. So this is in blocking mode. We want this though now to transition to a forwarding state. But the thing is, switch 2, the best BPDU that he knows about is from switch 1, and he thinks it's coming from this direction, right? So what's going to happen is it's going to take a while. Now, switch 3 is still sending these BPDUs in this direction. But it will take a while for this to transition. What's going to happen is switch 2 right away. So walking through this, as soon as this breaks, switch 2 is going to say, okay, I lost my root port. Root port is down. So I am the new root switch. Because switch 3 is forwarding BPDUs, but we know that switch 3 is not a superior switch. So I'm going to become the new, and I'm going to forward a new BPDU down the only port left, GI02. And even though we're in blocking mode, BPDUs are going to arrive on this interface. Generally, when in blocking mode, it means we're just going to ignore. But we're not going to ignore a new BPDU. This will actually cause an alert on switch 3. It's going to say, hey, I mean, it will receive it, but it'll understand that switch 2, okay, this is an inferior BPDU. But that should trigger something on switch 3. What that should trigger is that, hey, why is all of a sudden switch 2 forwarding to me an inferior BPDU when before it was forwarding me just a copy of the root BPDU? So that's going to signify a topology change. And as a matter of fact, switch 1, it depends on which happens first. Switch 1 will signal, or he should signal, a topology change. Well, let me think about that. I'm not sure if that'll happen. Because when we do in the virtual environment, when I shut down GI01, this interface will still show as up. And I believe switch 1 will actually still continue to send BPDUs down this way. They just won't go anywhere. It's kind of weird that way in this environment, but that's how that'll work. So what will happen with normal transition time is switch 3 will say, okay, I've now received an inferior BPDU here. So what's going to happen, though, is switch 3 at some point is also going to resend what he's always been sending down GI02, which is switch 1's superior BPDU. And then switch 2 will recognize, oh, actually, I can't be the root switch anymore. I'm actually hearing about the root, the superior BPDU now coming down this interface. So then it's going to transition from listening to learning to forwarding, and then at some point that will change also. He'll start sending BPDUs this way, superior BPDUs, the correct BPDUs. Switch 3 will know about the change, and this will shift from an alternate port to a designated port. And then our topology will converge even with when this interface is down. Now that all in all is probably going to take us about 50 seconds, the entire, So let's illustrate that, right? Let's do a ping continuous from here 192.168.1.5. Repeat. And then what we're going to do is go over here to switch 2. And we're going to shut down. Oh, let's debug first. Debug, spanning tree, detail. Events. Guys, if you want to see all the, this is not my, well, this is a variation of a lab, so it's not an exact repeat of what you could see on networklessons.com. It's slightly different, but essentially I learned all this on networklessons.com. If you want to see the full explanation, a professional explanation, definitely check out that resource. I don't take any credit for it. I'm just kind of repeating what I'm learning and explaining so that it will stick better in my mind, right? And that, that's why I'm not showing that on screen. But all right, so here we go. We got our pings running, and we're going to come over here to switch to, let's call out this. Let's pull it out, and then let's go to switch 2. And we'll say interface GI0, what was it? 0, and we're going to do shut. So spanning tree VLAN 1 had heard a root. Basically, it's saying, okay, switch 2 is sending me as we can see 2, right? It's sending me a BPDU. And I'm going to send a topology change notification actually to the tree. Oh, so it does send, yeah. So he also sees one coming from GI02. So he receives a topology change, and he's going to send, that's why these are important, right? Topology change. So now GI02 is going to start to transition to listening and to learning and eventually to forwarding. There we go. So we lost a number of pings here. All right, now we're going to introduce uplinkfast. And what uplinkfast, let's bring this back up. And we'll watch this reconvergence happen again. The purpose of uplinkfast, you can't really change the behavior so much of spanning tree. You can't really change the protocol, how it works. But uplinkfast is intended just to speed things up. Hence the name, uplinkfast, right? And the idea is to put it on these switches that are essentially uplinks, have uplinks to the root. And what you want these things to do is it's going to transition faster. So what will happen is these ports, they're going to transition their alternate ports faster, and it's going to reduce, I forget exactly what it is. I'm about to look it up again. That's why I'm glad I'm explaining it again, or attempting to explain it again. Okay, I was looking at the wrong lesson here. Let me go back to, spanning tree convergence and uplink fast. You see, this is sort of the table of contents here, folks, in this. So yeah, essentially a non-designated port, which in this case was this port. It's going to sort of bypass the listening and learning states, and it's going to go immediately to the forwarding state. So the other thing that uplinkfast does, well, I'll just explain that part first, right? So let's do the same exercise, and this time let's enable uplinkfast on our switches here. And this is a global command. Yeah, actually I only need to do it here. So we're going to say spanning tree uplinkfast. I think we'll see some messages here too. Yeah, setting bridge ID. I don't know what all that means, but oh, it looks like it changes the priority. Show spanning. It looks like it did something with this priority here. Wonder what that was before. 32769. Oh, he changed his own bridge priority, didn't he? I wonder why he did that. Notice, though, this is where we see uplinkfast has been enabled. So that's interesting. What do the other switches show? We don't have to do VLAN 1, but I do it just for practice. Yeah, 32769. So why did he change his priority? That was not explained in the lesson. Interesting. I'm gonna screen cap this, and we'll follow up on that. You know, curious minds want to know. All right, now what we're gonna do over here is we're gonna go back to switch 2. We've got our ping still running, right? And we're gonna do, just in case, I'm not sure how many pings I've run. All right. So now let's go to interface GI00 shut. Oh, did you change? You have 02 to listening. That should have transitioned faster. Now, I'm doing this a little different from... Okay, I think I know why. Yeah, I actually need to do this on the switch. See, that was the same, wasn't it? Okay, this is good because, yeah, that's the same number of pings. Might have been a little more. Okay, I'm glad I did that. Here's what we need to do. We need to enable it here on switch 2. All right, I need to think about why that is. So apparently, uplinkfast, it's going to change. It looks like it will transition spanning tree, but it will do that only when it detects a down or a connectivity issue on itself. So like this was indirect, but this should happen on switch 2. Let's see. Let's do, actually the way this lab is shown is we take down an interface, GI00. Let's do no shut here. Let's back up a little bit. Let's break the link here. Because then when this interface goes down, switch 3 is going to know right away that the interface is down. Obviously it doesn't in this case. Switch 2 knows it's down, but switch 3 doesn't. That's indirect failure. It should know this interface is down, and then it should bypass the listening and learning on GI02. Right? So let's see. Did I enable uplinkfast here? Show spanning tree VLAN 1. Okay, it's not running here. It is running here. This is alternate port. All right, so let's start the experiment again. Let's do our pings. And this time we're going to break this link. Interface GI01 shut. Okay, that did seem to go faster to me. Show spanning tree. Okay, that transitioned to a designated. It looked to me, I'm not using a timer here, but 1, 2, 3, 4, 5, 6, 7, 8 versus 1, 2, 3, 4, 5, 6, 7, 8. It's supposed to be 20 seconds. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yeah, so as we can see that it does work in this case. I'm wondering though, this leaves me wondering, the fact that I tried it over here shows that let's go back to our topology. So if I break the link here, it looks like if switch 3 detects and an interface has gone down, which really, if you think about it, what this means for switch 3, it lost its root port. So maybe that's the definition of uplinkfast, is when we lose our root port. I think there's a different scenario for this where there has been an indirect failure. I think that's backbonefast. Yeah, and I think what it's actually doing here is it is changing the forward, so it's eliminating the forward delay timer. Yeah, so see this forward delay is about 15 seconds. We're basically not going to delay transitioning the port to forwarding. We're not going to wait 15 seconds. We're going to immediately start forwarding. Let's look at our messages here. Over here, sorry. VLAN 1 sent topology change notice on Jazz 02. Line protocol changed. VLAN 1, new root port Jazz 02. Okay, so as you could see that, right after we did shut, it said, okay, I lost my root port. My new root port is Jazz 02. Boom. And port forwarding uplink VLAN 1 Jazz 02 moved to forwarding uplink fast. Nice. Okay, that's what we wanted, right? Generate TC trap for port Jazz 02. It's in a topology change notification. So what does that mean, right? That means that the MAC address aging time is going to transition from 300 seconds to 35 seconds, because that's equal to the forward delay. Let's see, forward delay is 15 and 20 seconds is, let's see, spanning tree timers, you've got hello timers, which is 2 seconds. You've got the forward delay, which is 15 seconds, and 20 seconds is a max age. Yeah. Show spanning max age 20 seconds. So the aging time will change from 300 seconds to the equivalent of the max age plus the forward delay, which is 35 seconds. So the topology change says, okay, flush your MAC tables in 35 seconds. That is a problem, though, as we could see with uplinkfast, is this would go even faster. That's still a while to wait for the MAC address table to change, because on switch 2, we're going to think, okay, the MAC address that I know for host 5 is coming from over here. But now I'm also going to hear it over here. So there could be a traffic issue while that timer is running. It's better than 5 minutes, but 35 seconds is still a long time, where we're going to still say we have this MAC address on port JS00. So what the uplinkfast is supposed to do, but I've been yet unable to capture, is create this really weird thing called a Ethernet multicast dummy frame. If you saw my post at Discord or on Twitter, I've asked the universe, hey, has anyone ever seen this? Because what it's supposed to do is switch 3 is supposed to say, all right, look, I know I was telling everybody this way that I know about all these MAC addresses, but I'm going to send a dummy MAC address this way, even though maybe R5 is not talking right now, so that switch 2 is going to learn that these MACs are actually this way now. But I can't find, there's even a dummy Ethernet dummy frame, and this is Cisco proprietary, with a reserved MAC address, multicast Ethernet MAC address. I don't remember exactly off the top of my head, but I'm going to pull it up now. Strangest thing, folks. I mean, you know, who would have known that there was something out there called a dummy? Apparently, it's also used with FlexLinks, Cisco FlexLinks, which would make sense. So I'm just going to do search for dummy in my drill sheet. And here it is, dummy multicast Ethernet address 01000 CCD CDCD. It's very similar to the L2PT Ethernet multicast address. I couldn't capture it. I tried to capture it here. I turned on packet captures. I never saw anything going to this destination Ethernet address. I looked all on the repository. Need more cats. Hey, packet thrower. Apparently so. Apparently need more cats out there monitoring the network and chasing the rats, because I want to shake out this rat, and I haven't been able to find it yet. It's sneaking around somewhere, but I can't find it. I'm thinking I need to use Real Gear. Maybe I would see it on Real Gear, or I read somewhere on Cisco Learning Network that someone said, it's, oh, do I have it wrong? Let me go back to that. Maybe I copied it wrong. 0100 0C CD CD. Yep, you're right, packet thrower. Exactly. It's in my drill sheet here. But yeah, it's like, even, you know, Wireshark didn't have it. Wireshark.org. At least not that I could find. I haven't Google searched this address, though. Let's do that, just for grins, folks. Let's Google search this address. Oh, Brad Hedlund, he has good stuff. The flooded multicast frame. Okay, that's a new name for it I have not seen yet. Uplink uplink-fast cam updates are not done via TC and TCA process, which that process takes, it's fine, that process works, but like I said, it's going to take 35 seconds. It's going to decrease the MAC address aging time from 300 to 35. We want to faster that. Rather, cam updates are done by flooding multicast frames containing the source MACs of all its locally known MACs. The destination MAC address of the flooded multicast frame is that. Okay. Can we get a... Routers running to send traffic to SP uplink reserved hard. Oh, HSRP does it too. Yeah, I've heard this called spoofing as well. An uplink transit the switch spoofs frames from each downstream client. The frames are sent to the uplink fast multicast address and flooded throughout the upstream portion of the spanning tree. The upstream switches don't need to be running uplink fast. Don't need to be Cisco switches. The regular MAC learning implement on any learning bridge will update the L2 forwarding tray table appropriately. Spoofed uplink fast packet. It really doesn't matter what's in a packet, but the catalyst in my lab send two. Yeah, I agree. So you really only need the source address coming in, right? To update your table. It doesn't matter. It could be all zeros in the payload. But the catalyst in my lab send 2 frames for each client. The first... I don't think that Cisco switches plenty, especially handling these, but I can't be sure about it. Okay, so this is reassuring in the least that someone saw it using catalyst switches. So that's good. While pondering posts, I noticed routers running HSRP in traffic. Okay, so HSRP does it. That goes nowhere. All right, let's keep searching. Yeah, this is an article I read earlier. Let's just try it again. Let's just see if, just in case I missed it right. This time I'm going to look at both of these ports. So let's capture on both of these ports. GI01. There we go. And GI02. Hopefully you have my ping stopped. Okay, they have. All right. So what I'm going to do is, whoa. Show interface status. Okay, so right now GI01 is disabled. No shut. All right, so now we should return to our normal operational state that we're expecting. I'm going to keep Googling this, by the way. It's got to be somewhere out there, folks. It can't just be a ghost. Tell me this is not just internet lore here. Dummy frames. No dummy frames. SP enter uplink. Read the link below. Dummy packets. Yeah, I read this earlier. This goes over the process in detail, so it's a good standard Cisco document. All right, so what we're going to do here is we're going to reset our captures. So we're going to stop. No packages were captured. Okay. I'm going to redo these. I'm not sure what's going on there. Oh, because the interface was down. That's why. That one really won't matter, but let's go to GI02. This is the one I captured before. Okay, this is GI01. GI02. Yeah, you might be mad at me. All right, let's go back. Try again. Capture GI02. Okay. All right, everything looks normal. We should see spanning tree BPDUs. We should see an occasional once every 60 seconds, a CDP. DTP is turned off. Remember, I turned off negotiation. So no DTP packets. All right, now let's transition this port again. Shut. Oh, I didn't do this right. Sorry. One more thing. The reason I have a couple of hosts on this topology is because, remember, it's only going to send dummy packets for hosts that it knows about. So theoretically, I have one host here that we're going to have to do a few pings so that this host is in his MAC address table. Then when we transition GI02 to a root port, switch 3 should generate a dummy packet or dummy frame because he knows about this host. He needs to update the other switches about this host MAC address. So before we just need to send a few packets or frames. Ping 192.168.1.4. There we go. If we look at... Okay, we may have done that too early. Let's do clear MAC address table dynamic. Show MAC address table. Okay, that is GI01. Okay, that's fine. Let's do this ping. Very good. So now we know about actually host 4 and host 5. And we know that host 5 is connected to GI03. All right, now we want our captures to start. And now we want to invoke uplinkfast. There we go. Boom. Okay, now all I'm going to see here are BPDUs and CDP as a destination, which we know CDP destination is shared with a number of other different types. But there's the destination address, right? Look at pvst. That's its destination address. Spanning tree for bridges is this destination address. I don't see any dummy packets. dummy frames. None whatsoever. And if we look over here to switch 2 now, see, he does not know about the other. So I just think this is probably not running on this image. This feature just must not be used on this image, because if he would have sent a dummy, let's say, all right, that switch 3 sent a dummy frame over GI02 and it came into GI02 and Wireshark, or just for some reason, is unable to detect that, or the switch software treats it a little differently as it processes it. I don't know, but if uplinkfast would work the way it's documented to, then this MAC address would be known by switch 2 on port GI02, but it doesn't. So, all right, now it does. No, it doesn't. Yeah, that's not the address we're looking for. This is not the MAC address you're looking for. Yeah, I still don't know about host 5. So it's just probably a feature. I mean, it piqued my curiosity. It's not a big deal. I can move on. I'm over it. But, you know, I use this hashtag frame hunter. I love to like hunt down packets, right? If there's something I haven't heard of before, or it's new or different, I'm like, I want to see that. I want to see that in Wireshark, you know? And now this one even piqued my curiosity even more, because it's like, okay, I didn't see it, and I can't even find a sample on the internet. Like, I found a sample Zigbee packet with 802.15.4 frames that you need special hardware to capture with. Okay, I found that. That was not a problem. But I can't find this, you know, righteously named Ethernet dummy multicast or spoof, right? So I'm still very intrigued, but I don't want to go too far down this rabbit hole and get oh, wait a second. I saw something different. What is this? Deck Mop remote console. I've seen this before. What in the heck is this? Ooh, I want to know what that is. All right, so I'm going to... If anybody wants to look that up or Google that and give me a little background, that'd be great. I mean, I'm very intrigued here. That is not new, but now that we're like frame hunting, I'm like, ooh, there's another wild animal in the wild. Let's shoot at that. Sorry, I'm not trying to say anything about like animal rights or anything. But I was like, Spanning Tree pvst, Spanning Tree pvst. Wait, and it's such an unusual name. All right, what we're going to do is we're going to say not STP. And not CDP. Yeah. Deck DNA remote console. Huh. All right, just humor me for a minute, folks. Humor me for just a second here. Let's go back to our Google search. We'll hit a couple more. Okay, here's a blog about this particular... It's in Spanish, but that's okay. I read Spanish. Oh, this is just looks like a repeat of someone else's content, to be honest. Yeah, no one has like a packet capture. Okay, I know about the gratuitous ARPs. That makes sense to me. Well, there they are here in the wild. There's no pcap, but that I can see, but it's in debugs. Wow, this looks like a really in-depth coverage of HSRP and VRRP. Wow, this is a monster of an article here. Who is this? Cisco Ninja. You are a ninja, man. What is this? Wow, I'm impressed. All right, back to what we're trying to find here. Cisco uplinkfast. Flashcards. All right. Yeah, you can't. That's another interesting thing I didn't mention. You can actually update this parameter. Max update rate. Let's look at that. Let's see if we can change this. Spanning tree uplink fast. It does. Max update rate. Maximum number of update packets per second. Show spanning tree. Does it tell me what it's using right now? Okay, that's cool. Number of transitions. Station update rate set to 150 packets per second. So we would have seen them by now. Okay, I saw this before. Yeah, that's all that does. Yeah, all right. Well, we'll let it go. And assume that I would have to see this on real gear. But I did want to look this up. Deck mop. What is deck mop remote console? AB. Let's save this, by the way. Export. Save as. Where are my options here? Oh well. 2018, 09, 01. It's September already, folks. Deck mop remote console. All right. Let's look that up real quick while the curiosity is piqued. How do I disable it? Decnet Maintenance Operation Protocol. I've heard of Decnet before. However, as of now, this is still enabled by default on all Cisco iOS releases from 9.0. Oh yeah, I remember from Cisco iOS 9.0. Wow, that's old. To disable MOP on the router has to be done on a per interface basis. I've seen it get silently enabled after an iOS upgrade because it included a switch from Advanced. Unfortunately, it's hard to get Cisco to change a default. No IP directed broadcast, yeah. Okay. Router spring cleaning, no mop required. Oh, that's good. I like that. Yeah, Deck. I knew who Deck was. Deck was purchased by Compaq, I think, which was purchased by... Or no, it was purchased by Digital, which was purchased by Compaq, which was purchased by HP, I think. Decnet, yeah. One of them was called DRP, and the was routing. It was NSP. Okay. MOP offered many features. All right. All right, I'm going to copy this blog here. So yeah, if you're curious, that's just kind of leftover stuff. Decnet MOP pack frame. All right, moving right along. So that is uplinkfast. We see how it works. Now, I wanted to play with backbonefast and compare that and the operation. And I believe this is the indirect link resolution here. Yeah, this is a scenario I really needed to demonstrate earlier, but we're going to turn off no span tree uplink fast, interface GI01, no shut. And now we're going to do it the other way. What that I started out doing is we're going to shut down the interface here. And backbonefast is going to work a little different. So as we saw already, when you have this uplink fast works great on a distribution switch when I guess what you would call traditionally a distribution layer switch that is connected to the root switch when it has a direct link failure, right? We saw it shave off quite a bit of time in transitioning what was otherwise an alternate port to a designated port, GI02. But what about an indirect link failure, which should be over here? So if we get this to drop, as we saw, it doesn't really help. Switch 3. Yes, there is a topology change notification, and that takes care of the problem normally by default, but that's still going to take like 30 pings. That's like 50 seconds. So backbonefast is really the answer to that. And what backbonefast does is when I receive a switch 3 an inferior BPDU, which will happen, like we said, we walked through this before. This fails, switch 2 says, oh, right away, I am now the root switch, and I'm going to make this a designated port, and I'm going to send a BPDU down this link. Switch 3 is not expecting to receive any BPDUs, inferior BPDUs on this interface. And when it does, and when you have backbonefast enabled, what happens is this is letting switch 3 know, hey, there's been a change in the topology. This is before like a TCN gets, basically a TCN might be sent this way, and he will get a TCN, may or may not, depending on necessarily your topology here. In this case, he will get a TCN. But then he forwards the TCN to switch 1. Then switch 1 forwards the TC back down. So there's still some delay there. And by enabling backbonefast, though, what we're saying is that if we get an inferior BPDU from a port we're not expecting to get one on, then that really tells us there's a topology change. We might get a TCN, we may not. We're not going to wait on that. In other words, we get an inferior BPDU, what we're going to do is initiate what's called an RLQ, which stands for, shoot, I knew it just a second ago. Root link query. Yeah, shoot, I should know that. It's going to send a root link query, which is just a way to say, hey, there's been a change somewhere, and I just need to verify who my root switch is. I know I'm still getting BPDUs on this port, but I'm going to send a RLQ, and I'm going to wait for RLQ response from the root. Once I have that, and I understand that this is still my root switch, then I'm going to go ahead and transition this port that I received a new inferior BPDU on. I'm going to go ahead and transition or skip the forwarding state. Let me just verify that I'm telling you the right thing here. It's going to skip the max age timer. It goes to listening and learning straight right away. We effectively save 20 seconds, right? I'm going to get to the max age timer in a minute. Going more deep, that's my last point on today's stream, but let's just demonstrate this. So what we're going to do, this should be root port, this should be alternate. Okay, root, alternate, designated, right. All right, so what we're going to do is, now backbonefast is a global command, and really backbonefast needs to be enabled in your entire topology because it needs to be able to support those RLQs. You know, right now we say, oh, I'm just going to enable it here and here because I'm going to send RLQs here. Yes, in this case you would, but what if there's another interface link change? You know, you really want to have it running on all your switches in your topology, in your, you know, in your VLAN domain. So in this case, we're going to enable it. Spanning tree, backbonefast. We should get some event messages here too. Span back. Use that command. Interesting, it does not show with uplinkfast. It had a line, it added a configuration here saying uplinkfast is enabled. Number of RLQs, okay, number of transition, none, 000, okay. We can see here that it's enabled, but we cannot see it here. So something to note. Why be consistent, right? Why not hide stuff in different parts of your outputs just to make it fun for the network operator? Let's keep them guessing. I know I'm being a little snarky there, but all right, so we now have, I don't have a start button. Oh, I do. I can do this. No. Well, let's just restart these. What we're going to do is I want to see these RLQ requests and responses. So I'm going to do a capture again on GI01 and GI02. Actually, let's just do GI01 just to keep our screen less cluttered here. Okay. So in this case, we're going to disable GI00. And we want to measure, we've already measured this when the topology is normal. So we're going to send pings. And when we disable this interface, switch 2 is going to be isolated until this alternate port comes back up. Let's see how long that takes. Ping 192.168.1.5, repeat. Okay. I just realized when I'm putting this down over here, my face is covering it up. Sorry about that. All right. So let's go over to backbonefast is now running. And we're going to cause an indirect link failure in our topology. Interface GI 0, 0, shut. All right, there we have I'm going to guess about 8. Okay, a little more than that, but I still think this is shaped because last time we had like 30 pings lost under normal conditions. So it's still a little slower than what we saw with the result of a direct link failure, which makes sense because you have to do the RLQ process, right? That's probably accounts for the difference. So we had 1, 2, 3, 4, 5. Pings are relative too, I know. So about 18 instead of 30. So we had 8 with a direct link failure and uplinkfast. We have 18 with backbonefast and an indirect link failure. And we have 30 packets lost through any kind of failure through normal spanning tree mechanism, right? So we are shaving off time. All this, of course, gets much better with RSTP, which we're going to see. I'm going to be studying about, next couple of days. All right, let's look for those RLQs. And I should see them on GI01. So let's stop this, and we're going to say not ICMP. Okay, we got some sort of TCNs. We expect those. All right, when did this go down? All right, there's our first TC. This is our first TCN. No, second TCN. So maybe, so what should have happened is, it looks like maybe the RLQ is encapsulated in a BPDU. So we should actually see switch 3 forwarding a BPDU. These are all coming from switch 1, right, which we expect. There's our TCN. So let's specify this as the source. Yeah, see, we would not normally expect switch 3 to send a BPDU to switch 1, right? But I think this is, and the other two are TCNs. So I think this was basically our RLQ. And I'll bet we find it embedded in here in a flag or something. It's not a TCN or a TCA. Huh. All right, let's Google this. If anybody has an idea, just shoot it out there. STP RLQ. There we have like a flow chart. Two forms of RQ: RQ requests and responses. The RQ request is sent out on a port we usually receive BPDUs. In order to check that you still have connectivity, specify in the request which bridge is your route. And the RQ response eventually comes. Okay, the RLQ PDU is the same packet structure as a normal STP PDU. The only difference is that two different SNAP addresses are used. One for request and one for the reply. Oh, so it's in the SNAP. Ah, okay. Control field. Destination SNAP is 0xAA. The message type used is also different from the standard PDU. The only fields used are the route ID and the sender. Okay, so let's compare side by side an RLQ. Ah, shoot. Close. All right, how to do this? So let's mark this. And let's look at all. Well, not ICMP. All right, let's go to our marked. Where was it? Did I lose my marking? I don't really know how that works. I haven't really used that too much. Okay, there we go. No. Okay, it's marked in black. All right. Oh, okay. All right. Is this it? Oh, I see. This little line right here is the marking, isn't it? Aha. Okay. So this is a normal. Ah, look at this. The DSAP is a different number. So the two differences are same as BPDU format, different DSAP and SSAP. Normal BPDU is what? 42. RLQ is... Boy, it's hard to pick one of these out, isn't it? All right, the other difference it says is... the message type. The only fields used are the route and the sender. All right, this is a request, by the way. So there's a different one for a reply. RLQ request. Let's find our reply. It will be coming from switch 1. Ah, okay. This is a normal BPDU from switch 1. And he proceeds. Oh, a lot of these are 0xAA. That's pvst plus. Hold on a second. We know this has to be it because... Oh, here it is, PID. Boom. There it is. So where is this? This is code 0108. Organization code. Control field is 03. Snap. Okay, there we go. DSAP, SSAP. Control field. Organization code. And protocol ID. Okay. That's it. Right there. That is the request. Now we should see a reply. That's pvst plus. It used the same... .0xAA. This is the response. All right. 109 is the response code. Okay. PID code for request is X108. PID code for response. Okay, cool. Mystery solved. Wow, there's really no way to differentiate this. It's funny. It's like, okay, we need all these functions to exist as part of spanning tree. And then they said, okay, we need these optional features. Do we want to create a new message type, or do we just use the existing message types that we have and fudge with some of the codes that are in there? Makes sense. It makes sense. Makes it harder for Wireshark to identify something, but okay, I think I screenshot that. Yeah, all right. So there it is. There's our... I'm going to save this. RLQ. All right, that is backbonefast. If we look at our... Interesting enough, I did not see... Do we need to have debug enabled for backbonefast? Because... Oh yeah, I didn't have STP enabled for... So if we do debug, spanning tree, backbone... Events... general... Yeah, I don't see one in this image for... Apparently some images have an actual debug command for backbonefast, and it'll show you that it receives those RLQs. So essentially, once it gets the RLQ response, it knows, okay, there's been a topology change in the network, but this is still a valid... It's just a check, you know, this is still a valid path for where my root switch is, and if this is a root port, I'm going to go ahead and skip the max age, which is 20 seconds, and we'll reconverge, and that port would go to listening, and then to learning, and then to forwarding, right? This port here. Then switch to now has a path, so good stuff, folks. What else we got today on the agenda? All right, so I need to clarify something. This is just a vlog. I talked the other day about the max age timer, and I had that wrong. So I had in concept, I had it correct. The part I had wrong about it was about the age. So essentially, the max age means 20 seconds. So that is the longest amount of time I'm going to honor or view that I have that the BPDU that I received that tells me where the root bridge is, that is an authoritative BPDU. And it has a timer on it, right? So if I don't receive a BPDU, I'm going to allow that to age out in 20 seconds. But what I was talking about is a spanning tree radius. And what I said yesterday is that as you go out from the root bridge to, for example, 1 hop away to 2 hops away, that the max age decreased 1 second per hop. And that's not correct. It's still always 20. The concept is the same, though, in that what happens is the message age is incremented. So from the root switch to its designated port and the next switch down, this is the root switch right here. So it sends max age 20, message age of 0. But this is 1 switch down. And what it's going to do is it's going to send, now this is what the switch sends. Wireshark has captured inbound the BPDU from the root switch. Here, Wireshark has captured inbound on 2 switches down what switch 1 sends, for example. And notice that it's not decrementing the max age timer, it's incrementing the message age by 1. So a lot of the timers in spanning tree are based on a maximum radius of 20 switches. That it's counting on the fact that you would never really have, because on switch 19 or switch 20, what's going to happen? You're going to have a max age of 20 and the message age is already going to be 20. So it's already going to view that as an invalid, this is an old, and it's not really going to be able to converge. So it's probably really 19. Well, no, it'd be 0 is at the root. Switch 1 is going to receive a 0. So yeah, it'd be 20 switches. So spanning tree, a lot of the timers, the 15, the 20, the max age, that's all based on a maximum radius of 20 switches. The old, spanning tree. So I have seen switch topologies approach that for a single VLAN. Ordinarily, you would not want to extend a VLAN that far out. Either you're not stacking switches, or you have, you're just really wanting to stretch a single VLAN really, really far. Maybe it's a management VLAN, for example, and you're still using legacy spanning tree. Not a good idea. So unless you want to play with your timers, and you don't want to play with your timers. So that's the idea behind it, and that's why they strongly encourage not, playing around with these timers. But as you can see, this is an X top down, message age is 2. So that's how that works. I want to clarify that from yesterday and what I said, because I said something erroneous. But anyway, glad we were able to clarify that. I'm going to pop out. I did not have a trivia question from yesterday, but I have one for tomorrow. I plan to stream probably at noon, my normal time. So we looked at some of those actually. I showed them some to you here on the stream. But what are the Ethernet multicast MAC addresses for pvst plus and spanning tree for bridges, which is the legacy 802.1d excuse me, spanning tree? Do you know those by memory? I wouldn't expect you to. I think I could probably recite them now, and I only know them because I've been using the flashcards getting ready for written. But anyway, try to think of them. If not, try to find your answer for tomorrow, and we'll go over that. And the only meat chunks I have, I really don't have any. I'm going to post this later. I will post the link to the new pcap. Actually, I can do that now. Take that back. I already have a link to the repo. Let me open this here. There's no pcaps. There's only one pcap there now, but I will be adding this for you folks. We'll be adding the one we used tonight. And I'm going to add all the past repos as well. Or the past repos. All the past pcaps that I've ever done. Yeah, packet captures. So, yep, if you want to clone it, here's a link to clone. And there we go. Thanks so much for hanging out, folks. I appreciate any who took time out from their, holiday weekend. You may or may not be doing some study this weekend. If you are, I had some folks in the chat. It was great to see everybody in the chat. So, hope you enjoy the rest of your weekend. And, keep on grinding. Keep studying. Keep learning. Keep working towards that cert or skill that you're working on, or, or labs, or whatever you may be doing. Wish you the best. I'm sending you good bits across the globe. They're instantaneous. The latency on the good bits from brain to brain is 0 latency. It's faster than the speed of light, just so you know. But thanks for hanging out, folks, and we shall see you. I will plan to stream tomorrow at noon. We may go out on an excursion tomorrow, or Monday. I'm not sure. We haven't nailed that down yet. So, but I'll target that anyway at noon tomorrow, and we shall see you back here sooner than later here on the Land Tamer stream. Good night, folks.